Alright guys, welcome to lesson 7.8. It's our last lesson for unit 7 and for semester 1. Today we're going to be learning how to graph rational functions. Here's the steps. If I were you, I would encourage you to pause the video here and take a moment to copy these steps down. We're going to be using them on every problem that we do today. So go ahead and have those handy and we'll begin. Alright, so here we go. Step 1 is to determine what the horizontal asymptotes are and the end behavior. So those two things kind of just go together. I'm going to show my work, I guess like right here, and then I'll be erasing my work after each step just because I'll need some space. But let me use black instead here. So end behavior is where we find out what's happening on the right of our function and where we find out what's happening on the left of our function here. All right, so as you guys know, we're just going to be taking the first two terms and making a fraction out of those. And when you reduce that, you end up with this, which is -1. And anytime you have just a number right there, the answer is -1. And the same thing is going to apply to the bottom here. Anytime you have just a, this is a horizontal asymptote, by the way. Anytime you have a number there, if you have an infinity, then there's no horizontal asymptote. But if you have a number, then that's your horizontal asymptote. And it's going to be the same for whether you're doing this limit or this limit. So my answer for number 1, for the first step, is I'm going to go ahead and write this out. The limit as x approaches infinity for, and I'm just going to put the function here so I don't have to write out the entire thing. And what we end up with is -1. And the same thing applies to the left-handed limit as well. And that's my end behavior. So what that means is that I have a horizontal asymptote. Okay? So now after each step, when possible, we're going to graph what we just found. So I just found my end behavior. So I know that on the right side of my graph, my function is going to have a flat line at -1. So I'll draw that now. It's going to get flat on the left, and it's also going to get flat on the right at -1. Okay, so that's my horizontal asymptote. That's my end behavior. All right, so moving on to step 2, we're going to go ahead and we're going to graph our y-intercept. Now to find your y-intercept, basically all you do for that is you plug 0 in for x. Now if you plug in 0 for x, all of these terms are just going to go away, which is going to leave me with 12 over -3, which is -4. So my y-intercept is at -4. So now I'm going to graph that. After each step, graph what you can. So I know that my function is going to touch the x-axis right there. Not the x-axis, the y-axis, right there at -4. All right, step 3 is to factor this polynomial or this rational expression. So for this, I would encourage you guys to pause the video here, and I would have you guys factor it at this point because you want to start getting some practice with your factoring a little bit to make sure that you're good with that. Because if you can't factor, you're going to be paralyzed to do the rest of the problem, so you need to know how to factor. So pause the video here and see if you guys can factor it. And when you unpause it, I'll show you what I got by factoring it. All right, and so this is what I get. I would suspect that most of you guys got the top okay. The bottom, maybe your answer is a little different than mine because I really want to encourage you guys to do what I do. I've told you in multiple lessons, I like to factor this negative number out first from the entire polynomial. And even though it's kind of optional in a sense, if you don't do that in this lesson, you're going to find that sometimes your factors won't match up as much as you want them to. So it's a good idea to go ahead and factor out the -1 first and then do the box method. And that way you'll end up with what I have there. Okay. if you don't have what I have there, go ahead and make your corrections, and then we'll move on to the next step. So now there's no graphing that you have to do for step 3. No graphing needed for step 3. But on pretty much every other step, there's going to be something about the graph that you have to do every time you graph it. So let's go ahead and do number 4 here. Number 4 is to identify the holes. The holes are located where you have a factor that cancels from the top and bottom. In this case, we happen to have one. The x minus 3 cancels, so I'm going to take that x minus 3 and set it equal to 0. And that tells me that I'm going to have a hole located at x equals 3. Now technically you can't graph a hole until you get to the very end, but I do like to put a little note on my graph so that I remember to do that at the end. So I like to put like a little H right where x equals 3, just so I remember when I'm all done graphing this to put a hole there. Okay. Let's move on to step 5. On step 5, what we do is we find the roots. Now the roots can be found by taking whatever factors are left over in the numerator, setting those equal to 0, and solving. And that's what we learned in our last lesson. So we have a root at 4. So I'm going to go ahead and put a dot at x equals 4 on the x-axis, because that's what a root is. It's a place where your graph will touch the x-axis. All right. Next thing we're going to do is we're going to do the vertical asymptotes. The vertical asymptotes are located where whatever factors that are left on the bottom equals 0. So we have x minus 1 equals 0. We're going to add 1, and therefore I have a vertical asymptote at x equals 1. So now I'm going to put a dotted line going down my graph at x equals 1 there. Okay. So now comes our newest step, which is a little bit, is going to seem a little odd. But basically, here's before we do that next step, which is going to be kind of new for you guys. I just want to let you guys know what we're going to do. Basically, I want to connect everything together. Okay. Now sometimes you can just connect everything together the way it is, and you will have the correct answer. So for instance, I know that it has to connect to this arrow over here on the left, and then it has to touch that dot, and then it's got to squeeze up against that asymptote. So the left half is probably going to end up looking like that. Okay? And on this other side, I know it's got to connect to this line. It's got to go up, it's got to hit this root, and then it's probably going to swing up and get close up against that asymptote like that. Okay? And that's probably what the graph is going to be. Now sometimes though, we're not too sure what the graph is going to look like. Sometimes there's just not enough information. And so basically what we're going to do is we're going to plug in a few more points and just find a few more dots so we can make sure that our graph is actually looking like what we might expect it to. So now on this one, personally, I would probably skip this next step myself if I was graphing it, but I'm going to do all the steps on every problem today. And if you ever get to step 6 and feel like, hey, I can connect these dots and I don't need to do step 7, I'll leave that up to you. It's just that sometimes if you don't do step 7, you will not get the correct answer, just as a fair warning. All right, so step 7 is basically to plug in some points. Now, what points should we plug in? Well, basically, we want to plug in any points that are in between our roots and vertical asymptotes. So, for instance, I've got a root at 4 and a vertical asymptote at 1. So I want to pick a point in here somewhere. And I probably, I'm not going to pick the hole either. Matter of fact, let me rephrase myself. We should probably pick a point that's in between the holes, roots, and vertical asymptotes. So I want to pick a point that's in between the hole and one that's in between the hole and the root, and we'd probably want to pick another point after the root, and then we'd probably want to pick another point to the left of the asymptote. So anything that is we want to pick up numbers that are in between the holes, roots, and asymptote, vertical asymptotes. And so I have 4 points that I want to plug in, okay? And the purpose of this, like I said, is just to give us a little bit more information so that our graph looks the way that we would expect it to, okay? All right, so let's go ahead and pick a point on the pink region there. So pick any number that is from 1 off to the left forever. It doesn't matter what you pick, but let's go ahead and just randomly say, okay, I'm going to pick x equals -2. Change my color there, though. I'm going to make that pink. I'm going to pick x equals -2. Now let's pick a point from the green region there. Anything between 1 and 3. Well, I think a really obvious choice would be 2, right? If you don't have to plug in fractions, don't, because plugging in fractions is no fun, which is what we kind of have to do here on the next one. So in between the whole and the root, that's between 3 and 4. So we have to pick a number between 3 and 4. So let's go ahead and just go with 3.5. Okay? And then finally, we want to pick a number to the right of our root, which let's just go ahead and do 6. I don't like to pick numbers that are too close to the dots if I can avoid it. So I'm not going to pick 5. I'm going to go ahead and pick something a little further. Let's say 6. There we go. So basically, we're going to plug in these 4 x values into our function to find out what the y value is that goes with it. Okay? Now, you can use the original function if you want to, so you can plug them in up here. But personally, I find it a little bit easier to use this one because we've already taken pieces of it away, which makes less work for us to do when we're calculating it. So my advice is use the factored form from step 3 to do that. Okay, so I went ahead and plugged in -2 to my factored and reduced form in step 3. And let's see what we get as a result. On the top, I get -6. And on the bottom, -2 take away 1 is -3, times -1 is +3, and I end up with -2 as an answer. And so that's the y value that goes with that x value up there. So now technically I could plot that dot at -2, -2. So let's go ahead and plot that. -2, -2 would be right here. Okay? Matter of fact, I think I'm going to erase that dot there. I don't want that there anymore. All right, so we're plotting a dot at -2, -2. So now I've got another dot, and that just gives me more information for my graph. Okay, so we're just basically getting more spots, and we're picking numbers that are in between the spots that we already have, basically. All right, let's go ahead and do the next one here, x equals 2. So I'm going to plug it in once again to my factored form. Why don't you guys go ahead and pause the video here and do the other 3 and then plot your points. And when you unpause the video, I'll show you what I got. So this is what I get by plugging in those numbers there. All right, so let's go ahead and do the green one. For the green one, at x equals 2, I get y equals 2. So that gives me another dot right here at 2, 2. We also have -0.2 when x equals 3.5. So at 3.5, y is a little bit below the x-axis. So at 3.5, we're going to be like right about here. And then finally at x equals 6, we're at a y value of also a little bit below the x-axis. So but just maybe a little bit more below the x-axis, so maybe like right about there. Okay? So just to clean up my picture now, I think I'm going to try to erase some of these extra marks on here. They're kind of in my way that I don't want. Clean it up, and then we'll get going here. All right, so I think I need to put the h back because I lost the h. The h was right here at 3. All right, so there's my graph. And so basically just need to connect the dots now that we have. So starting from the left arrow, we're going to come down, hit that dot, and squeeze up against that asymptote. Same thing over here, we're going to come up, hit that dot, swing up, and hug up against that asymptote. Now the last thing we want to do is we don't want to forget the hole, because remember the hole is the thing that we want to do at the very end. There's supposed to be a hole in this graph at x equals 3. So I'm going to find a spot on my graph where x equals 3, which would probably be like right about there. And I'm going to put an open circle there to indicate that that is a hole in the graph. And there we go. Now we're all done. And that's how we're going to graph rational functions. Quite a few steps to it. The most tedious of which is 7. But basically, you're just picking numbers that are in between your holes, roots, and asymptotes, plugging them in so you can get a few extra points so that you have more information to connect dots with and complete your picture. Okay? So let's go ahead and do the next ones. Now, as we progress through more and more of these problems, I'm going to be gradually asking you guys to do more and more of the steps as we go, just so you can get used to it. All right, so let's go ahead and move on to another one. All right, so let's go ahead and take a look at another example here. So this time I would like you guys to go ahead and pause the video and see if you guys can figure out what the end behavior of this function would be. When you unpause the video, I will show you the solution. All right, so there's the answer number 1. Since you have x over x squared, whenever you take those and reduce them, you end up with negative 1 over x, which anytime you have just an x on the bottom, it goes to 0 at infinity. So that's the answer there, and that's my horizontal asymptote. So pause the video here and see if you guys can sketch the left and right hand arrows of this function on the graph. And when you unpause the video, you'll see my graph. So since there's a horizontal asymptote at 0, we would have an arrow on the left and the right on the x-axis where y equals 0. So that's where my graph will be at the far left and right hand ends of this graph. Okay? All right, let's go ahead and move on to step 2. Step 2 is to find the y-intercept. So go ahead and pause the video here and see if you guys can find your y-intercept. And when you unpause the video, you will see my solution to the y-intercept. The y-intercept is a little bit weird on this one. When you plug in 0, you end up with 4/9. Okay, so that's a small number. If you want to change it into a decimal, it might help you understand what it is a little bit more. So if we do 4 divided by 9, we're going to get about 0.4. So we're going to plot that now. So let's go ahead and plot a decimal, or I'm say a dot at 0.4. So that would probably be like somewhere like right about here. So it's going to touch the x-axis right about there at that point. Okay? All right, let's go ahead and do step 3. Step 3 is to factor it. Once again, pause the video and see if you guys can accurately factor this thing. And when you're done, you'll see my solution to the factoring. And there it is. On the top, we would take out a negative. And on the bottom, we would do difference of squares. Step 4, we would look to see if there's any holes. But as you can see, there are none. Holes are where you have a factor on the top and the bottom that are the same, and we don't have that here. So this graph will not have any holes in it. Go ahead and pause the video here, and I want you guys to do steps 5 and 6. Do both of those steps, please. Okay, so the answer number 5 is -4. The answer step 6 is 3 and -3. And now I want you guys to graph these things. Remember, the answer that we got for 5 is a root, whereas the answer number 6 are vertical asymptotes. So go ahead and graph those two things, please. Okay, so we've got my root. I've got a dot plotted there at -4 on the x-axis. And then I've got my two vertical asymptotes there represented by the vertical dotted lines. One is at 3 and the other is at -3. All right, now we get to challenge you guys a little bit. This part will be a little bit trickier. I want you guys to begin doing step 7 with me, but in step 7, I want you guys to see if you could pick some points, okay? So remember, I want to pick some points that are in between each root, which is right here, and each vertical asymptote, which is right here. So we need to find a point to the left and right of every root and vertical asymptote up there. And I'll give you a hint. You should have 1, 2, 3, 4 points to pick. Now, not everybody would pick the same thing, but just pick some, and then we'll see if your choices are good choices. Pause the video here. When you unpause it, I'll show you the results. So now you don't need to color code your graph like I do. I'm just doing that for teaching purposes. But we have 4 colored regions up there that I've highlighted: green, orange, pink, and blue. You need to pick one number from each of those intervals, okay? So I'm going to pick one from the green region there, which would be, it doesn't matter what you pick, but I'll go ahead and I'll pick x equals -6. And then I'll pick one from the pink region. I already have a dot at x equals 0, so I don't want to use that. Let's use let's use x equals -2. And then how about x equals 6 from the blue region? I think I missed one actually. Let me back up. I just realized I didn't pick one from the little orange region there. The orange region is the area that's in between -4 and -3. So that's one of our decimal ones. So unfortunately, we're going to have a little decimal in there. So back to the pink, we said I was going to do -2. And then for the blue, I was going to do 6. And I'm running out of space here, so I'm going to have to erase some stuff in a minute. But those are my choices. All right, so now I want you guys to plug these points that we've chosen in to our factored form of the function. So plug each one of these in and see what you get for the y value for each one of those x's that we've chosen. And then when you're done, plot those points. And when you unpause the video, I'll show you what I got. All right, so here's what I got. For x equals -6, I got 0.1. So at -6, I'm going to put a dot a little bit above the x-axis. 0.1 is really tiny, so it's going to be like right about there. Next, for the orange one, when I plugged in -3.5, I got -0.2. So at -3.5, we're going to have a dot that's below the x-axis, probably like right about there. Okay, and then for the pink one, when I plugged in -2, I got 0.4, which is going to be about in the middle. And then at 6, I got -0.4. So at 6, we got -0.4, which is going to be down here. And now here's the interesting part. I want you guys to try to connect these dots together. Now let me give you guys some advice before you do, okay? First of all, you got to obviously connect the dots to the arrows. Second of all, you can't cross these dotted lines. Those are asymptotes. So it's got to squeeze up against the asymptote. Third of all, whenever you're connecting everything together, I want you guys to notice something. If there's no roots, then you can't touch the x-axis. Like for instance, from here to here, you guys see how there's no roots? There's no dots on the x-axis? You're not allowed to cross the x-axis. And that means the whole thing in between those two vertical lines has to be above the x-axis. Okay? And the reason for that is because we don't have any dots where our graph crosses the x-axis there. We looked for those and there are none. So it has to stay above the x-axis there. All right? So go ahead and pause the video and see if you guys can accurately connect all these dots together to get a good picture. Okay, so I'm going to go ahead and do it now. So starting with the arrow on the left, I'm going to draw a line. It's going to touch that green dot, and then it's going to hit the red dot, then the orange dot. And then after that, I see it's going down. So I'm just going to continue that trend. And it's never going to be able to cross that dotted line, but it will get close to it. Now on this other side here, I know that these two dots need to connect together, but it also has to keep going this way. So now it can't cross that dotted line. So what it's going to do is it's going to swing up. And the reason it's going to swing up and not down is because, as I told you, it can't go down and cross the x-axis anymore. Same thing happens on this other side. It's going to go up and then squeeze up against that dotted line. Okay? Now on this other side over here, we're going to start in the arrow on the right. We're going to come down, we're going to hit the dot, and then after that, since it's on a downward trend, we're just going to keep going in a downward direction. And so that's what the graph will come out looking like for that particular function. All right, so let's go ahead and do another one. I'm just going to do a couple of these until we start to, I feel like you guys have gotten enough practice to feel comfortable. All right, so this time, instead of having you guys do each step one at a time, I'm going to let you guys try to do this entire problem by yourself. So go ahead and do all 7 steps on your own and see how far you can go with it, okay? And when you unpause the video, I will show you what I did. All right, so I stopped at step 6 just because I want to make sure that we're good up to this point at least. So my horizontal asymptote is at 0, so I'll sketch that. My y-intercept is at 1. There's my factored polynomial on 3. There's no holes. And we have a root at -2. And we have a vertical asymptote at -3. And we also have a vertical asymptote at 2. And now we want to make sure that you guys pick some points to plug in between every root and vertical asymptote. So for me, we have 4 regions, once again, to look at. We have from here to here. We have in between the asymptote and the root right there. And then we have between the root and the next asymptote. And then we have here. So I'm going to go ahead and plug in some numbers for those 3 regions myself right now. I'll plug them in, and then I'll put the rest up. So by plugging in these points that I chose, I get a positive half whenever it's at -6, so that's going to be like right about there. And then we get a -0.7 at when x is -2.5, so it'd be like right about here. And then we have when x equals 1, y equals 3. And then finally, for -1.3, when y is -1.3 when we have 4, so that would probably be like right about here. And so now, check your dots. If not, you might want to correct those. And then now you want to connect the dots. And if you connect those, we see that this one would have to go like this. It has to stay above the x-axis because there's no roots there. These ones are going to connect like this. And then this one would connect like this. It's got to stay below the x-axis because there's no roots on that side. So that one will look like that. Okay? So hopefully you guys are starting to feel a little more comfortable with it. I want to do 2 more problems with you. One of them I will do completely, and well, I'll have you help me a little bit with a guided practice, but the last one will let you guys try to do completely on your own. So what's mainly different about this one is the very first step. Okay, so let's go ahead and do the first step. Now, for the first step, we want to find the end behavior, right? So I'm going to take the first term off the top, the first term off the bottom, and then I'm going to simplify that, which is x over 4, which we talked about before. We kind of like to rewrite that in this fashion. And we talked about that yesterday. Now, when you have a positive number here and an odd power here, that means that as my function is going to the right, my graph will be going up. So that's what I'm going to put right here. The limit of my function as x goes to infinity is infinity. And what that means is that the right half of my graph is going up. Okay? We want to do the same thing for going to the left, though. So whenever you have these kind, you have to kind of do it twice in a sense. Actually, we kind of do and we kind of don't. You just need to look at the chart. On our chart, when you have a positive number here and an odd here, the graph goes down on the left. So for this one, it's going to be down on the left. So that would look like that. So the left side of my graph is going to be a downward facing arrow, and the right side of my graph is going to be an upward facing arrow. So there's no asymptote on these ones. So let's go ahead and write that down too. No horizontal asymptote. Anytime you have infinities as an answer instead of a number, there are no horizontal asymptotes. Okay, so I'm going to draw an upward arrow on the right, and I'm going to draw a downward arrow on the left. Okay, there's my end behavior for the function. Now the rest of the steps really aren't all that different. So I'll buzz through those a little bit quicker. So step 2, we want to find our y-intercept. If I plug in 0, I end up with 0 over 8. And so that means that my y-intercept is just 0. Okay. Number 3, we want to factor it. We can take an x out of the numerator. In the bottom, we can take a 4 out. And since there's no factors on the top and bottom that are the same, there are no holes in this function. All right, moving on to steps 5 and 6. To find our roots, we take the top factors and set them both equal to 0. So we have x equals 0, and we also have x minus 2 equals 0. For this one, I have to add 2. And so I see that I have 2 roots, x equals 2 and x equals 0. For step 6, we take the factor on the bottom, set that equal to 0, and that tells me that my vertical asymptote will be at -2. So I'm going to plot all that right now for steps 5 and 6. For step 5, I had 2 roots. I had a root at 0. I had a root at 2. And then for step 6, I had a vertical asymptote at -2. And there's that. Okay? Now, let's go ahead and move on into step 7. Now, I'm going to do something right now, and I want to show you guys you actually don't have to do step 7. And that's good news, because step 7 is kind of like the step that is the most work and kind of a little bit confusing. So we can actually avoid it if you just think about it. We can actually just try. Sometimes you don't have enough information. But I think in this case, we actually have enough information to be able to get a good graph. So I will still do step 7, but I just want to show you how sometimes you don't need to. So I know that the arrow has to start up here, right, on this side. It's got to come down, and it's got to hit that root, and then it's got to hit that root, which means that it has only one way to go after that, and that's up. It can't go back down, because if it did, that would cause another root to happen here, and there isn't one. So it has to look like that on the right side. Now on this other side, it cannot cross the x-axis, right? So that means it's got to swing back down at some point and hug up against the asymptote like that. So as you can see, you really don't even need to do step 7 a lot of the time. But I like to teach it because there are some cases where you can't. And also I think there are some students who just kind of appreciate having a few more points to connect along the way. So I'll still do it. So let me pick some points to plug in here. I'll pick one from this region over here, which would be, let's say, x equals -4. And I'll also pick one in this region. We'll say -1. And then I'll pick one from this region, which would be +1. And then I'll pick one in this region, which we'll say is 4. I'm going to plug those into the fraction over here at the right. And when I unpause the video, you'll see my answers for those. So plugging those x values in, I get those y values, and I can plot these points. So I'll plot -4, -3, which would be about here. And then we have -1 and 0.75, a positive value. And then we have 1 and -0.1, which which would be down here, really close to the x-axis. And then we have 4 and a positive 0.3, which would be like right about here. And so now we've got a few more dots to go with. So it's got to come down here like that, like we said. Go like that, kind of like what we said. And there's our graph. So the only thing that was really different this time about this problem was step 1, the in behavior. We didn't have a horizontal asymptote to graph, but we did have a left-hand arrow and a right-hand arrow to graph, which indicated whether the graph was going up or down. So you need to look at that chart that we went over in our last lesson to know which way the arrows will be going. All right, so one more problem for today. Here it is. This is another example of a problem that doesn't have any asymptotes. So go ahead and see if you guys can graph it. I'm just going to let you guys go ahead and handle it from beginning to end completely on your own, and we'll see how you do. Okay, once again, I did mine without doing step 7, but I'll let you guys study this real quick, see if you guys disagree with anything I have on steps 1 through 6. But after that, I'll show you how I drew my graphs without doing step 7, because you oftentimes don't need to, okay? But if you want to do step 7, more power to you. Okay, so starting here on the left, I'm going to come down, it's got to hit that dot, and then it's going to squeeze up against the asymptote. That's the only way that could possibly happen. I guess a technical possibility is it could technically bounce off of this axis and come up like that. That's probably not going to happen though. And if you were unsure of that, you could just do a test point. So if you pick a number between these two, -4 and -3, I think what you're going to find is that you end up getting a negative number, and therefore it's going to come down. Okay? But you can always do a test point if you want to. But on this one here, it's going to start on the right side. It's going to come, hit that dot, and after that it can only go up. It can't go back down because we're not allowed to touch the x-axis again. There's no other roots in that region. So as you can see, you don't necessarily have to do step 7, but I at least wanted to share it with you in case you ever get to a place where you're just not too sure. So if you can't seem to get a graph based on steps 1 through 6, go ahead and do step 7 to get a few more dots and see if that helps you out. Okay? But that kind of does it for us for the day. So we'll go ahead and stop there. And from here on out, it's study guide, test, and then we get 3 weeks off. So see you guys in class next time.